welcome back to some of you. For those of you who sat through the last presentation, this one's going to look somewhat similar, but some things different. So I'm Dennis Peters, Chair of Electrical and Computer Engineering. I'm here to talk about why you should choose electrical engineering. And so just a brief outline of where we're going. Talk a little bit about career options, a little bit about the courses in the program. I've got a guest speaker here. Unfortunately, one canceled on me at the last moment. And then I'll leave you with a few resources. So the question, why choose electrical engineering? I put to you, what do you want to do? How would you like to spend your life? Because it's not about the program, it's not about the courses, it's more about what you're going to do after you graduate. And I apologize to those who've seen this before, which is going to look similar. Make the world go round. And electrical engineers do find themselves in telecommunications, power generation, distribution, sustainable energy. Those are obvious key marketplaces, key technologies in our lives these days, and they're in all of our lives. Certainly when the power goes down, we notice it pretty quickly. And so there's obviously lots of electrical engineers in that area. And these are key technologies in our lives. You want to design things that people use, and of course, most of the quote-unquote technology that we use on a daily basis involves some electrical. Everything from our laptops to our phones to whatever, there's electrical design in all of those. Cars and planes, lots of interesting stuff going on for example, in the hybrid electric vehicles these days, primarily driven by electrical systems. By the way, most big boats, they actually run on the so-called diesel electric. So what they actually have is a big diesel engine that's a generator to run to power an electric motor to drive the boat. So most not a 50 or 60 footer, but a cruise ship or a large ship, it's running a diesel electric. So there's electrical engineering even in the shipping, right? So lots of stuff. If you want to get into boats, you want to get into cars, you want to get into planes, not a bad spot to be. Have an impact on people's lives. Power does so much. Electricity, and electrical engineering is not only about power. I don't want to give that impression, but we have an impact on many things, whether it be in our modern lives. But one of the things that's actually real interesting, and I'll take this one, partially because it's the one that the people who are here for the computer side didn't see yet. Here's one. Thinking about microhydro.
From 1996, UNDP has been supporting the establishment of micro-hydro plants in the rural areas of Nepal not connected to the national electricity grid. So far, 380 plants have been established with UNDP support, generating a total of 7.2 megawatts of power and benefiting more than 77,000 households. This January, a 24-kilowatt marine polar micro-hydro plant that will benefit 234 households in Amade village in Sindhuri was inaugurated.
यो मरिन खोला लगजलगी त 24 किलोवाटको हो 234 घरधुरीलाई बिजुली पुर्याउँछ यसले यसलाई विभिन्न किसिमको उद्योग धन्दामा प्रयोग गरेर यो बिजुलीलाई बढीभन्दा बढी प्रयोग गरेर आय आर्जनको काममा गाउँको मानिसहरूको आय आर्जनमा वृद्धि गरेर जीवनस्तर नै माथि उठाउनलाई हामी प्रयास गर्नेछौँ।
अहिले जमानामा कम्प्युटर बिना कुनै पनि काम गर्न सकिँदैन। अब कम्प्युटर सिक्न लागि हामीले घर छोडेर बाहिर कोठा लिएर सदरमुकाममा बस्नुपर्ने अवस्था थियो। अब अहिले बत्ती आएपछि घरमै कम्प्युटर राखेर सिकेर अब घरको कामै भ्याइने र अब हामीले कम्प्युटर पनि घर सिक्न पाइने धेरै फाइदा हुन्छ।
यहाँ आएर गाउँलेहरूसँग भेट्दाखेरि उनीहरूको उत्साह देख्दाखेरि चाहिँ धेरै नै खुसी लाग्ने कुरा चाहिँ हुन्छ।
Nepal, only 20% of rural area has renewable energy access, and actually we have abundant of water in this country. The microhydro can be really the key for poverty reduction. The villagers are now thinking about how to use electricity, not only to have lights at night. So start very, very small business, and from there expand their livelihood. So microhydro can be a key for poverty reduction.
So that's just an example of one of the ways that we might, electrical engineers have a big impact. And I show that one because it's a particularly feel-good one. Micro hydro systems, and what they're talking about there is a small hydroelectric plant that they put into, where you have a small river or something, you can build a little reservoir, you can run a simple generator. In developing nations, that can have a huge impact on people's lives, bringing electricity into a community. And as you saw those people there talking about the kinds of things that you can change, whether that be running lights for a hospital or just bringing electricity to home so they can work on computers and so on, all those things. So those are real impacts you can have as an electrical engineer. It's just an example. And once again, helping people learn, lots of other things you can do, education technology, just technology. Power and electricity is part of almost everything we do. And what I'll say, if we save lives, well, try and call 911 without the phone, right? Very simple. It's an electrical system. And once again, try and run an operating room without electricity or without control systems or whatever. So there's lots and lots of stuff going on there. Electrical engineers, like all engineers, frankly, are not guys who sit in dark rooms and work on their own. They are parts of teams. And so if you like working with people, it's a good place to be. And to be honest, this is about the same for all disciplines of engineering. You're not going to, as an engineer, most likely you're going to be working as part of a team, probably part of a multidisciplinary team involving other branches of engineering, other technical people and non-technical people, whether that be writing or what have you. So lots of people interactions is natural in any real job these days. Do you want to make some money? Here's some statistics close to home. This is from the Paganel, the Professional Engineers and Geoscientists in Newfoundland and Labrador member salary survey. So they surveyed the members of Paganel. In fact, this is, I'm not sure, this might be for Atlantic Canada. The survey is done by Atlantic Canada wide, so this might be Atlantic Canada, it might be Newfoundland. And so looking at salary by discipline for, yes, all associations. So this is Atlantic Canada associations. And these are the mean and the median salaries by discipline. Electrical right up at the top. Not way out ahead of the others, but if you think that those guys who are in mechanical are getting more money in the oil industry, the numbers aren't bearing it out. That's the truth of the salary survey, and this is 2012 data. So that's what we have there. For those of you who are thinking, oh, computer engineering, why is computer engineering not here? It's because there's not enough computer engineering graduates to register on the stats. So I think they probably are done for other. The other thing is registration of computer engineers is a little less popular than for all the disciplines. Anyway, there's good money in any engineering discipline. There's if you're wondering which one you're going to make the most money in, well, according to these numbers, electrical is not a bad place to go. Where's the innovation going? Where's the fun happening? Well, fun for an engineer has to do with innovation. investment in R&D. That's where engineers do stuff that they like. And so the top 2,000 worldwide companies ranked by best investment in R&D. Here's the top 24. And now you're going to say, okay, some of these are fairly mostly computer, Microsoft, Intel, Google. They're pretty strongly computer companies. Apple's probably in their search. No, Apple's not in the top 24. But in terms of, there's also a fair bit of electrical going on, certainly in places like Samsung, Siemens, Panasonic, Sony, Cisco. Those would be a fair bit of electrical going on in those ones for sure. And even the other ones, even ones that you think of as being primarily computer. Well, Intel is really actually an electrical one. That's a device level for the most part. Microsoft, they're hiring both. They're hiring electrical and computer. There's lots of stuff, excuse me, in both electrical and computer going on there. And looking at the other ones here, Volkswagen, Toyota, Bosch, Honda, Ford. Some of those other ones you'll recognize as being General Motors, excuse me, you'll recognize as being obviously car companies in the automotive industry. Well, ask yourself what kind of innovation, where's the innovation happening in cars these days? Is it in the mechanical side? Not so much. It's lots and lots of electrical and computer control systems, all this sort of stuff going on in cars. And so a car is truly a multidisciplinary project. It has an awful lot of computer engineering in it, as I've said, an awful lot of electrical engineering in it, and a little bit of mechanical still in there too. So where might you work as an electrical engineer? You might be in the power area, transmission, distribution, utilization. You might be in electronics, instrumentation, and control. You might be in communications or remote sensing. These are some sort of areas you might work in. The industries, obviously power, utilities, telecommunications sector, oil and gas. You think of oil and gas, well, you got to do a process or mechanical to get an oil and gas job. Not true. Lots of electricals and computers in oil and gas. Technology, niche technology, there's lots and lots of them around. And yeah, electricals are in all of them, pretty much. A list of employers, once again, these are ones I've just pulled off on the top of my head. These are employers who, I can name somebody who's gone to work for them either permanently or on a work job. And some of these will be familiar names, of course. There's obviously the power utilities, in the heavy industry, resource sector, the oil companies and so on, Hatch. Lots of electrical at Hatch, by the way. They're a big multinational engineering company. And the high-tech sector, it's easy for me to name these, because these are the ones I personally work with mostly. A lot of these actually spun out of the university one way or another, a lot of these companies, and these are regular hirers of our students and our graduates. So lots and lots of employers around. So that's a little bit about what you might want to do. Talk a little bit about the program structure. Electrical and computer are pretty much the same up until term 4. The first, the first 3 terms after term 3, was term 3, 4, 5, and 6 are mostly required courses. That's the way all of our programs are structured. They're very strictly structured through the first little bit, and then in the last 2 we give you lots of room for electives. And by the way, there's in the senior part of the last 2 terms, 7 and 8, you do your what's called your capstone design project, and this is similarly done in most of the programs. In electrical and computer engineering, we actually do joint projects between electrical and computer engineers. So you work on a team project, and you will typically have some electricals and computers in the same team working on some project. And the capstone design project is you get to build something, or design something. Typically, electrical ECE students will build something. actually make a product, a demo of some real product. That's one of the neat things about both electrical and computer engineering is you do actually get to build real things. Whereas in civil engineering, it's unlikely you're going to build a bridge as part of your program. I can assure you in electrical engineering you will build real circuits. And in computer engineering you will write real programs. So the team project is kind of cool. And at the open house, which is going to happen on the 24th, I hope to have some of these projects around to show you what some of the cool stuff that our students do. The courses, electrical engineering, going to do analog and digital circuits, more math, yes, a little bit more programming. In electrical, you do one more programming course than you do in engineering one. Then you do things like signal processing and communications, control systems, instrumentation, power, and electromagnetics and antenna system. So just the general areas. Here's the specifics. If you want to talk about anything specific. So as you can see, these are all term 3, 4, 5, and 6. Fairly strongly required courses. You've got one technical elective there in term 6. And you get a choice of 2 courses, either you're going to do power or you're going to do networks. And then when we get into the senior 2 terms, term 7 and 8, there's a lot more flexibility. You get 3 technical electives in term 7, and 3 electives in term 8 as well. So 2 of them are technical and 1 is so-called free. Okay. Any questions up to there? So I had arranged for 2 speakers. One of them unfortunately just canceled on me this morning, so I had 1 speaker. Scott is here. And so Scott is an electrical engineering student of the class of 2014. All going well, right, Scott? Yep. Why don't I get you to come up and you can introduce yourself, tell us a little bit about where you worked, and then we'll have time for some questions and answers. Just stand so Adrian can catch you.
So my name's Scott Henderson. I'm in term 8 electrical, as Dr. Peters mentioned. Most of my work terms have been in power utility industry, and the courses choices that I've been doing in term 6 up through term 8 have been in that industry as well. I guess that's what I enjoy most about the work term, or the school, is being able to relate it to the work terms experience. That's what I find the most interesting.
Okay. Do you guys have any questions?
Yeah, the way we plan to do this, I guess, is to have a bit more of like a question and answer period. I didn't really have a lot prepared to talk about.
And that's the templates for you guys to ask.
What companies have you worked for locally?
My first 2 work terms were with Newfoundland Power. So I worked in like their Duffy Place office, which is their operations area. So it's where all the line trucks come in and out. That's also where they do their distribution planning. So it's looking at the distribution networks of the lines and poles that are behind your house, and I guess looking at how they need to be expanded as more customers are added. My 3rd work term was with General Dynamics in Calgary. So it was a different work term. That was more like they do a lot of military contract work, and it was a bit of a communications work term. And my last 3 were all with Nalcor. I did 1 in the electrical department and another 2 in the system planning department.
Other questions? I've got a couple of them up my sleeve if we get stalled. I'd really like them to come from you. Yeah?
What are you doing for your design project?
For the design project, we're doing a resident power transfer system. I don't know if you ever watched TED Talks, but there's one on that called Witricity. So we're trying to recreate that, and we're looking at implementing it underwater. So since we're trying to light like a 60-watt light bulb by powering it across here, so there's going to be like 2 antennas that are placed a certain distance apart. So we're working on that, and we're doing it with Solus. They're a local company that's working on it, and they're helping us out in the lab. So that's pretty neat being able to see, I guess, that industry.
Is another question? Oh, same one. So what was your favorite one?
My work terms with Nalcor and system planning I like the most. So those are my last 2. What I liked about it, I guess, is like I said again, the link to the schoolwork. It's like I'm doing a course now, power system operations, and the calculations that we're doing on tests and on exams are the same calculations I work out like on a notepad on my desk at work. So we build like verify all the computer simulations and make sure everything's working as it should in theory. So that's pretty fun. It makes like the school seem a lot more valuable too. Just it makes you more motivated when you get back into school. And two, like when I was with New Flame Power, I remember I did, on one of my work terms, I went out to Beta Sphere and I looked at a generator, and they were doing testing of like a new stator, so that's part of the generator. Then when I came back to school the next term, we did a rotating machine scores, and part of the labs was doing the exact same tests on small machines that they have downstairs in the basement. So that's something that you can do in electrical that you don't really get to do in mechanical or civil even. You don't get to go, I guess if you're working on designing like systems for Hibernia and stuff like that, you don't necessarily get to go to the lab and really see it on a small scale. So that's one of the things I like most about my work terms and the labs in school in general.
You mentioned sustainability and like environmentalism in the involvement in electrical engineering. Can you like elaborate on that? Like how does that play a part?
Okay, sure. Lots of electrical engineers are interested in renewable energy, for example. That's clearly plays into the sustainability. So, wind energy, and in fact, I saw a research talk this morning about power electronics for dealing with renewable energy, which there's lots of implications of putting that onto the grid. So huge areas of research right now on how to do that properly. So that's the obvious one, right?
There's a spot in like Ramia where the government's put a whole bunch of money into building all kinds of renewable energy systems. So they have like wind turbines, they have a hydrogen diesel combination system where they take the wind energy and store it as hydrogen and burn it later for gas. That's something that like Nalcor has a lot of employees that work with it. There's also a couple wind farms around. There's one in St. Lawrence. There's one in like down the Southern Shore, and both of those are staffed by companies here. And they're like two of the top producing wind farms in all the world. Like they get really high capacity factors is what they call them, just because it's so windy and it's windy like consistently and it's always high. So there's lots of jobs there, and even like through Nalcor you can get involved with that kind of work.
The other thing, on the side, of course, is designing for sustainability. One of the issues that as engineers we need to think about is when we design something, what's its total life cycle? Where does it go? After we're done with it, or after the consumer's done with it, or whatever. How does that? So that falls into all engineering disciplines. Electrical is part of that. Designing for more efficiency, not using more energy. All those things like that. Yeah.
Why do you prefer power as opposed to any of the other specializations?
I guess the main reason was my first few work terms were in power, and I really got to like it at that point, and I'd see it all implemented in school and on the work terms. But my first two work terms I really enjoyed, and that kind of led me to move in that direction. I know some people who work in communication as well, but I find a lot of the communication jobs are away. So if you want to work with like really detailed hardware design, you got to go to Ontario. There's like Sierra is one company that does it. There's also a lot of stuff with General Dynamics, which again is away. Here there's some companies as well, but I guess when I was thinking about it initially, I kind of only saw the ones away. And as like I moved through the career, I noticed a lot more were here. But another thing with power too, you get to see it all implemented. Like there's a lot of engineers here that will get to travel to remote sites all around and look at the power systems there. So you get a lot of travel, and you can meet lots of people, and you work on the ground with a lot of like tradespeople. So it can be a lot of field work, which is a lot of fun too. Instead of just being stuck in an office or a lab all day.
Any other questions? Yes?
I have a question for you. Is electrical engineering more theoretical or practical?
Is electrical engineering more theoretical or practical? Well, it's not engineering if it's all theory, right? Engineering is about solving real problems, not solving theoretical problems. And so, yeah, it's an applied discipline. It's quite practical in terms of what we do. Now, you may say, okay, look at the courses. Back up. You're looking at these courses. You might say, well, mathematics, circuit analysis, those are sounding pretty theoretical, maybe. But well, those are real circuits you're working on. The math, you're doing the math because it's useful. This math is used in all these other courses, right? And it really means something. When engineers use math to solve real problems. So yeah, although it's a foundation, there's a theoretical foundation that you have to get. It's ultimately quite practical and quite hands-on. We have labs in a good portion of our courses here.
One thing I noticed is that like you start off like the first few terms you do a lot more theoretical courses, and as you progress like you combine a lot of the aspects of different courses and they like become parts of bigger systems which are more practical. Like for like power systems, for example, like all your circuit analysis comes into play and all your electromagnetics for the transformers and for your generations like all build up to more applicable courses I find.
Other questions?
What have you learned in your courses that you could like do at your own home? Like I know you learn about theoretical stuff, but what's something that you could just pick up on a weekend and like a project that you can complete?
Like one thing that right now like the Term 5s are working on is they build like an emergency light system. So they have a couple sensors to detect like when the light goes off, like it's plugged into the wall so that if the power goes off and if it's dark in the room, it has a light bulb and a battery that charges itself and then the light will come on when the power goes off. I know a lot of people in our class still have their lights, like they use them at home all the time. You can get involved in, like some people do like home automation systems and like they work on them themselves, and if you want to break it down into a more detailed level, you can like program it yourself and you can build some of your own circuitry for that. That's two things I can think of. And like repairing things or doing like household wiring, like you have a bit of an idea on how it all works, so you can troubleshoot like problems around your house. Like if your dishwasher broke, you can look at a schematic and figure out what parts might be blown and stuff like that.
Any other questions? I'm going to throw one at you. Scott, so why did you choose electrical? And were your preconceptions were accurate?
I guess at first I was considering, I wanted to do something that had like a bit of field work.